Πού είναι η παρουσίαση, να ανοίγω κατευθείαν? Are you sure? Can we minimize? Hello everyone, can you hear me?
Yes, we can.
Anybody?
We can hear you.
Perfectly. Okay. Can we start?
Mr. Ioannis, can you hear me?
Yes, I can hear you. There's a little bit of back echo, but now it's over. I don't know if you can hear me.
Yeah, we can hear you. We are waiting, so once you are ready, when you have the opportunity, please start.
Okay, I'm ready to start. If you are ready, then we can go ahead, okay?
Okay.
Do you see the presentation? Review the presentation.
Yeah, we can see the presentations. Just check the chat area, which is at the left side down, in order to see any comments or questions.
Okay. Okay. So let's start. First of all, I'd like to thank being with me on this presentation. I'm truly sorry that I cannot be with you in Strathclyde, but as you maybe know, we are within a peculiar situation here in Greece. Let's call it force majeure, which did not permit me to join you. However, I'll do my best from this office to deliver this presentation and to be at your disposal for any further questions and discussion. The presentation that I'm going to make deals with how to initiate a design that covers LNG retrofit on an existing ship. This means that we are going to discuss on a real ship and what has been so far and what is ahead of the design team. This presentation is being delivered by EP, one of the beneficiaries of the program, and it is presented by myself. My name is Ioannis Bakas. I'm a mechanical engineer holding the position of the technical manager of LNG. LNG, just for the record, is an affiliated company to EP, dedicated to LNG solutions, marine solutions, and port solutions. Before starting, you will allow me to stress out a point. This content should be considered as business in confidence. What it means that I'm going to present you facts and data, as I told you, from an actual tip. This means that you should consider this data as not free for distribution, and in case you need any further distribution or any further usage of them, you should first obtain a written approval by both EP and the ship owner, which is Minon Lines. This is for the records, and let's go now to the contents. Don't be scared. I have 11 chapters to discuss. Don't be afraid of. Some of them are more detailed than others, and some of them are only 1 or 2 slides. So we'll pass it very quickly. Let's start with the lecture introduction. What is this lecture about, and what you are going to hear from me? As I'm written here, the purpose of this lecture is to highlight the difficulties that the design team is facing. For the sake of this presentation, I'm going to call the whole team of project managers, mechanical engineers, naval architects, etc., as under the word designer. So hereafter, whenever you hear the word the designer, does not mean one person, does not mean me, for example, but a whole team of persons that they are working close together and close to other industries as well. So the LNG solution on board includes every aspect of the design that needs to go forth in order to incorporate the solution. It also needs the equipment selection, what kind of equipment to be selected, why, and under which circumstances. Of course, it means the actual job on board in order to install this equipment. It also covers the very essential and very tricky part of the business, which is class approval, and I'll come back later to this because it is very interesting on how to cooperate and collaborate with class surveyors. And last but by no means least, it also should cover the after-sales service and the warranties that we'll have on the final job. All this will be discussed, as I told you before, on a real case basis. The real ship that is subject of this presentation is the cruise ferry called Festos Pallas. It is of Greek ownership, flies the Greek flag, and serves a domestic route. Since Minon Lines, the owner of the vessel, participates with the PE on another EU co-funded program called Costa 2 East Poseidon Med, agreed to present the ship for the sake of this module and within the frame of this on the MoS Way program. Let's go to the introduction of the LNG as marine fuel. I'm sure that everybody is aware of what is LNG and why we are going to use it as marine fuel, but allow me a very brief introduction to this fuel in order to have the global picture. Since I'm not a chemical engineer, I'm just a mechanical engineer, I followed the easy way. I went to Wikipedia, I clicked the link LNG, and I made some copies that you can find over here. Just a very, very brief explanation. LNG stands for liquefied gas, natural gas. That is natural gas that has been converted to liquid. Why, we will see later. The natural gas is a fossil fuel within the last 2,000 years with layers of dead plant gases that have been exposed to intense heat and pressure within the soil. Natural gas can be, let's say, obtained from the land in one way direction. We cannot renewable this kind of fuel source. It's like oil. Natural gas, of course, is a hydrocarbon gas mixture, mainly consisting of methane, but also includes other amounts of kinds and sometimes some small percentages of carbon dioxide, nitrogen, etc. It is an energy source. It's used for many years now. It's not a new business. Natural gas is used for few decades, not say a lot of decades. It's used mainly for urban applications like heating, cooking, and electricity generation. Recently, within the last couple of decades, it is also used as fuel for land and marine vehicles as well. And this is going to be our interesting point. LNG now is natural gas that has been cooled into liquid, reduced size to 1/6, and we are talking about progressive pressurizing the gas down up to the temperature of minus 160 to minus 164 degrees centigrade. We're doing this, the synthesis is very simple. We're doing this because it's very easy to support the natural gas. Pure physics, everybody knows that in order to move a gas, we need pressure. We cannot move natural gas in a long distance. We have limitations from a pump capacity point of view and piping point of view. That's why we introduced the liquid methodology, and this is now the reason that almost all quantities of natural gas are first of all liquefied and then being transported by ships or trucks. This is a summarizing of what is the natural gas to LNG and back forward. It's nothing important, it's just for the visualizing of what has been discussed. Let's discussing some more interesting fields. I would like to introduce the vessel to you and the route and the owner. As I told you before, the subject vessel is Festos Pallas. I'm writing down also the IMO number because every vessel has a personalized, let's say, ID through the IMO number. The ship is being named after the known Pallas in the ancient Festos. Festos was the second most important Cretan city. It was inhabited since 4,000 years. Festos Pallas was ordered in 1998. It is the second vessel of a total batch of 4 vessels and one type. And this is now a tribune, and I'm sure our Italian colleagues will be most happy to know that these ships have been designed in Fincantieri in Genoa, Italy. It's really, the Italian engineers really research are quite unique. Just for the records, I need to tell you that when the first vessel of this class was delivered, MoS Palas, in late 2000, the international press, the international maritime press, named this vessel as the best fast crew ferry of the year, and the acronym that was given here was a triple F, Fincantieri's Ferry Ferrari, was the triple F acronym for this vessel. Okay, of course it was designed and constructed by Fincantieri, but it was especially for the Piraeus Heraklion. Heraklion is a major city of, I'll show you later on the route. And it is worth to note that this ship never changed this route. She never abandoned the route because it made our life easier later on when we started calculating her operational profile. Together with her twin sister, Festos Palas belongs to a completely new breed of cruise ferries, I think still holding the title of the fastest displaced cruise ferry ever built. The interior design was done by the Italian studio Tesorio, which resulted in a very important technical characteristics of the vessel are being summarized in this with a total length of 240 meters, perpendiculars of 191.2 meters, a beam of 26.4 meters. You can see the depth 10 meters, draft 7.1, total of 37, almost 33.5 thousand, 37.5 thousand, and a net tonnage of close to 16,000. The full displacement of this vessel is around to 20,000 tons. We're talking about a big vessel. She is carried for many reasons. The previous model of the 16 popular engine of Wärtsilä, and please keep this in mind because later on, when we are coming to the retrofit, we will have an explanation why Wärtsilä is dealing in a different way on this particular engine. The maximum wind rating of both engines is more than 67,000 kilowatts, turning two controllable pitch propellers at 500 RPM each. The passenger capacity is 2,200 passengers, and the car capacity is 660 in full configuration, or 155 when we combine the cars with the lorries, with trucks. The length, we're talking about 1,560 lane meters, which approximately returns to 125 large trucks. Service speed as built was 29.5 knots. Right now the ship operates in a far lower speeds, and we're talking that she operates now in the region of 21.5. The maximum continuous speed, not the top speed, the continuous speed is 31.2 knots. You can see that there is further one for building up more speed, and just for the records, this ship achieved close to 2 knots at 100 MCR during sea trials. Some photos I need to display to you. Photos are free. I took them in traffic. On the left, you see the ship in the airport just before one typical night departure for Heraklion. At the right, you can see her at sea. And then again, more photos. external photos in order to highlight the fact that it is a cruise vessel, actually, but it's not actually Aeropax, it's more Aeropax. You can see the dining room and the airtight seats with each with its own TV set, and you see some lounges and the pool area as well. The owner of the vessel is Mignon Lines. Mignon Lines has been established in Crete 43 years ago in 1972. It was established with exclusively to the local community. Today, however, let's say, achieved a peak period regarding ship ownership in between 1995 to 2005, when Mignon operated around 12 vessels. Now, however, Mignon owns only 3 vessels. Those 2 sisters, Festos and another vessel, which operates in Western Mediterranean, and operate 5. Now, Mignon Lines is a member of the multi-group of companies, and the other 2 ships that I mentioned, that Mignon operates, are operating in the Adriatic Sea. Mignon, of course, dominates the Piraeus-Heraklion route and has a strong presence through Grimaldi Group in the Adriatic, as well as to the Western Mediterranean area, Italy to Morocco mainly. This is the route. I placed a snapshot of the actual traffic path, sailing path of the vessel. You can see this is Piraeus and this is Heraklion, and the vessel follows an almost straight line. The distance one way is 172 nautical miles, 73. The ship sails at around 21 knots, and in a few times per year she also performs some morning express sailings, during which she sails at around 26 knots. The typical night duration of slow trip is 9 hours, and the typical express duration morning trip is approximately 7 hours. It's one of the easiest and smoothest ferry connections in Greek islands. The ship is not suffering, let's say, from many hours of sailing. She stays at the port for more than 8 hours per time, and the crew has the time to perform some maintenance work on board. Now, let's go to chapter 4, which is now the design starting point for the LNG retrofit. Did I miss a question or something? No? Please try to turn off this camera because we do not have good audio. Okay, shall I continue? Okay. Design inputs. Let's discuss and let me present to you why are those necessary and of what kind should be in order the designer to start a proper work. Everybody, I'm sure, can easily understand why some inputs are important for the designer to start. Without them, there is going to be no solid result whatsoever, and any technical solution that will come out of the designer is in danger of being jeopardized during actual implementation. This means that the designer, if he doesn't have any inputs, then he might face a catastrophe, allow me the expression, a catastrophe during implementation. The key inputs that the designer is looking at can be categorized into three categories. The first category covers the operational profile of the vessel right now. This means that the designer needs to know exactly how the vessel operates in marine fuel, doesn't matter, and this is needed for one reason. To formulate the appropriate model, to calculate consumptions, and eventually calculate the necessary LNG tank capacity. This is the very starting point. We need to save our tank. Without this figure, anything else is useless to go forth. The second family of inputs is the actual technical information of the vessel. The designer must have access, full access to be honest, to the as-built or even newer technical information of the vessel in order to proper and correct calculate the status of the vessel after the retrofit. When we are talking to technical information, let me highlight the fact that we are not talking about a general arrangement drawing and some principal characteristics that somebody can find in, let's say, in marine literature or in a maritime magazine. We are talking about shipyard documentation. We are talking about as-fitted drawings and calculations and studies, things that are not circulating freely. This is why the designer must obtain this information from the owner or, if directed accordingly, from the shipyard. The third family of the inputs is for the designer to know how the owner is planning to operate the vessel after the retrofit. I know it sounds tricky, but if you don't have an input from the owner on how he feels that his vessel should operate after the retrofit, then he can proceed with making some mistakes in the overall retrofit. I will explain this later on. Let's take one of these families, each one of these families, and expand a little bit the inputs. For the annual operation vessels profile, we went to Minoan and we asked the right questions, and they gave us the right answers. And these are recorded herein. As you may see, the vessel operates around 350 days per year, which is a huge amount of usage, annual usage. And indeed, I personally raised the question to Minoan, okay guys, your vessel is close to constantly annual operation. And the answer that I received was astonishing. We only stop for 2 days for New Year's Eve and Easter Sunday, and we only stop for around 10 days for our annual dry docking. The rest of the year, we are constantly on the route. So, we are talking about a vessel that, okay, sails within a very easy line, but sails constantly. And she also performs daily departures from either ports. Let's say Monday, Wednesday and Friday from Piraeus, Tuesday, Thursday and Saturday from Heraklion, and again the circulation. When we are talking about 350 times, we are talking about the slow night voyage with an approximate speed of 20 knots. And this has been done, as I told you before, from each port in turn. In addition to these 350 sailings, during summer, as we speak right now, the ship performs 30 express service between Piraeus and Heraklion, and this is done with a fast speed of 26 knots, and this is a day departure. Typically, the vessel sails from Piraeus at 11 o'clock in the morning, arrives early in Heraklion, and then sails at night from Heraklion on a slow departure. In every case, both for night slow voyages and day express voyages, the vessel is operating with only 2 of her engines. She is running on only 2 engines. The second pair of engines is on a standby mode when the ship approaches the ports. Other than that, the vessel sails only on 2 of her engines in order to achieve fuel economy. Regarding the bunkering operations, these are taking place only in port of Piraeus, not in Heraklion in any case, and typically the vessel receives bunkers once per week. This is a typical case because it might be a case that the ship will request additional bunkering due to express services, but normally we are talking about once per week. The second, let's say, family of inputs, as I explained earlier, is the access to the technical information, the technical documentation of the vessel, and what kind of the equipment to be selected for the LNG retrofit. In that particular case, we were very lucky. We were very lucky because the consulting engineering firm that initially consulted Minoan Lines during the design and the construction of those ships is NAP. NAP is a company that together with Minoan are participating in the Poseidon Med program, and as you may easily understand, the whole technical documentation of this vessel is available for the LNG retrofit design. On top of that, Minoan Lines agreed to grant full access to the vessel, not only to the technical documentation, but to the vessel herself. This means, and this is a very useful input that you will see the results later on, this means that they told us, guys, feel free to enter the ship whenever you want. If you want to sail with her in order to monitor something, be our guest. If you want to enter her while she is port, just make a phone call and the crew will be at your disposal. So from this point of view, we are extremely lucky. We do have the full technical documentation of the ship available. The other question that we raised and we discussed with Minoan is, of course, how many engines will be retrofitted in order to burn both LNG and fuel oil. On top of that, while we are discussing this, we raised the question that we are talking about an older model of Wärtsilä. Please bear in mind that the particular engine type was designed and constructed in 1999, which is 16 years ago, almost 16 years ago. And although the Wärtsilä 46 is still in production, we are talking about later models. And right now we are talking about an earlier model that needs to be retrofitted. The answer of Minoan will be displayed later on, but before this, we went to Wärtsilä. We took up the phones, we arranged a meeting with Wärtsilä engineers here in Piraeus, and we sat together within a table and said, okay guys, we have an old model, please tell us what you can do and what you cannot do on this particular engine. And they told us that since it is an old type, out of production engine, they do need to virtually rebuild the engine in order to be able to burn LNG. What does it mean? It means that the old 46 model will be transformed to a brand new Wärtsilä 50 model. 50, for the records, the model 50 is exactly like the model 46, but with the ability to burn LNG as well. This means that Wärtsilä stated that if the retrofit will go ahead, and I'm sure that the retrofit will go ahead, they will dismantle the engine completely. They will leave untouched only the engine base, and then they will rebuild the engine with new components. So we are not talking about just a retrofit kit, which is normally a batch of valves and control systems that applies on top of the engine head in order to be able to use LNG as well. We are talking about a completely rebuild of the existing engine. Some of you might thought right now that this is going to be an expensive exercise. I can tell you right now that yes, that's the case. A major cost of this retrofit will be devoted to this particular part of the retrofit. The final question that was raised to me, Noam, was that are you considered also for the LNG retrofit some generators? I need to brief you on this point that when we are talking about generators on this particular vessel, we are talking about big generators. Each generator has a capacity of around 2,000 kilowatts. We're talking about engines that they are propulsing other smaller vessels. It's not a small generator, it's a huge generator. So this is the second family of inputs that we asked from Noam, and later on I will make clear to you what was the response. I need to highlight to you a trick. What does it mean? It means that if for any reason you cannot obtain access to the technical literature of your vessel, of the vessel that you are standing for the LNG, or if the owner is not willing to give you any access, or if the shipyard says that, okay, my design is not for you, it's not freely distributed, etc., you can propose, in order to bypass this difficult case, you can propose to sign an NDA. NDA stands for Non-Disclosure Agreement, and is, let's say, an agreement between two parties that will exchange sensitive information, and every party is obliged to follow the rules of the NDA. I did this particular exercise, and I signed an NDA with Hyundai shipyard regarding another vessel, a car carrier, and I signed this back to back with the owner, of course. But this was the case. The owner said, sorry, my ship, although it's my ship, I do not have access to the design because the design is not mine, belongs to the shipyard. And then Hyundai said, yes, okay, I can grant you access to this design, but please note that this is my, this belongs to me, all rights belongs to me, and let's sign an NDA. And this is how we bypassed this difficulty, and we were able to exchange technical information on the particular vessel. So this is a good trick to keep in mind that in some cases you may raise the solution of the NDA. The third family of inputs is how the vessel operations after the LNG retrofit. Now, why it is important for the designer to know how the owner will operate the vessel after the design, after the LNG retrofit? To be honest, simply, we don't care. We only care about one vital point, how he is thinking about the bunkering, the LNG bunkering. If, for example, the owner leaves this to us completely, to the designer completely, says, I don't mind, do whatever you want, then the approach will be the easy way, to install as small LNG tanks as possible and to force the owner to bunker every single day. If, for example, the owner, on the other hand, and this is the case for Minoan as well, tell us that, guys, I don't want to change the bunkering pattern as it is right now with the fuel, then this is our key point, take it into consideration and say, okay, I need to put into calculations also this fact that the ship will be bunkered once per week. What does it mean? It means that the capacity of the tanks must be such in order to allow for weekly, let's say, bunkering. All kinds of inputs can be accepted. Just for the records, and I'm sure you've noticed that during your visit in Finland and in Sweden, the Viking Grace is being bunkered every single day. It's their decision. It's not right or wrong. It's up to each owner to decide, but the designer must know how the owner thinks about it. Otherwise, we may both face troubles when the retrofit is in progress and suddenly the owner says, okay, what's going on here? Why you didn't ask me? And the designer might say, why you didn't notify me? And then you have a bottlenecking. So, in all these three, let's say, family of inputs, Minoan Lines cooperated with us in detail, and they provided the following feedback. How many engines will be retrofitted? Only 2 main engines. And this is based now on the fact that there is no need whatsoever to retrofit all 4 engines. As I told you before, the ship sails only with 2 engines, and the second pair is in standby mode regarding maneuvering when entering and leaving the port. Now, it was highlighted, clearly highlighted to Minoan that we are going to retrofit 1 pair only. This means that the Minoan will not anymore have the flexibility to exchange the engine pairs in operation. Because right now what they are doing, when they're sailing from Piraeus to Heraklion, they are putting, let's say, the first pair of engines in operation, and when they are sailing from Heraklion to Piraeus, they are putting on the second pair of engines in order to keep the operating hours in a balance. This is clearly explained to them, and they clearly accept it. There is no need for consider the re-engineering of the vessel because, as I explained to you, Wärtsilä has a solution for these old engines, and this solution has been communicated to Minoan together with the actual cost. Wärtsilä made an offer, and Minoan said, okay, we can consider this solution, please proceed accordingly. Regarding the diesel generators, no diesel generator will be considered for LNG retrofit. This means that the diesel generators will continue to operate in marine gas oil or fuel oil, depending on the case. And what is the owner approach for LNG bunkering procedure? Minoan expressed their willingness to keep the bunkering practice and pattern. This means that they would like to see Festos Palas bunkered with LNG once per import. And this is critical for us because for our capacity calculations of the tank, we needed to take into consideration. So, let's summarize the inputs. We have the full operational vessels profile. We have access to the technical literature, and we have a clear picture regarding how the vessel will be bunkered with LNG. Based on the above, the starting point now has been clearly defined, and we were able to start our first design. That is to start dimensioning, calculating the capacity based on the Wärtsilä input of consumption, LNG consumption for the Wärtsilä 50 engine. Please remember what I told you about the rebuilding of the 46 50. So Wärtsilä gave us the consumptions, and we were able to calculate the capacity of the tank. This means that immediately afterwards we went to the suppliers, and we said we do need to draw for a tank or two or three to tell us with this capacity. Please consult us on which is the best solution. Later on, I will show you the solution. Of the definition of starting point, and after being able to make the very initial definition, and I repeat, this is the required LNG tank capacity for the specific journey of the vessel, sailing of the vessel. We are now heading towards the next difficult design, that is where to place those LNG tanks on board. And the critical question here is to place them inside or outside. What does it mean inside and outside? Very soon I will let you know, I will explain to you. And of course, a full analysis and decision tools should be applied in order to answer this question. Although I'm pretty sure that you are aware of this, let me briefly tell you that the LNG tank does not come alone. It is followed by a number of equipment with, let's say, strange names, for example, cold box. And all this, they do consist a unit, let's say, one unit that the purpose of it is to hold and store the LNG after bunkering, and then to be able to distribute it to the engines for consumption. The typical LNG retrofit equipment includes, of course, tanks, cold box, which is a closed box that contains the regasification equipment. And what that means? It means that it is the point where the LNG becomes again NG, natural gas, in order to be able to be brought to the main engine for consumption. The cold box is, of course, all valves, evaporators, release systems, nitrogen injecting system, everything that is necessary to operate in a completely safe mode. We are talking about the GVU is the gas valve unit that receives the natural gas from the cold box. Of course, we are talking about the LNG bunkering stations, which always should be two, one at the port side and the other on the starboard side. You should never consider one bunker station unless we're talking about a very small vessel. Bunker stations should always be in pair, because you never know under which circumstances the vessel will be able to bunker. The bunker stations, of course, are connected with the necessary piping, which is again a very tricky and a very, not dangerous, but a suspicious point for the design, and I will come later to this as well. Then we are talking about the normal, it's a normal piping, double wall piping, but it's a normal piping, nothing, let's say, curious about this, is the gas distribution piping, the GVU use the main engine gas receiving point. Of course, we have dedicated relay systems and network for each space that contains the above equipment. We are talking about the gas release system, which is a system that allows the gas to be escaped in the atmosphere in case of emergency, either from the tank or from the cox. We are talking about the emergency shutdown device, which is an electronic patch of equipment that monitors constantly what is going inside the tank and what is going on inside the cold box, etc. In case of emergency, isolates the system. And naturally, last but by no means, we're talking about control, electric connections, firefighting, life-saving, escape, all these key that IG according to the question class needs to see on board. It gives the designer a very good headache. Let's press a little sometimes in order to bring the full picture. Your notice. This is a very simple schematic of what we are talking about. We are starting with a bunker station, which is receiving the LNG from an outside source. It might be a truck or it might be a bunker vessel. We don't care for the moment. We are going to see what's happening after the bunker station. So there is a line that brings the LNG to the LNG type C tank. The connection is we might be used the other part of the tank for filling. This is the filling up methodology, or it might in some cases also use to fill the tank from below. This is the filling down procedure. In principle, we are using the upper part of the tank. Then we have the cold box with a dotted line. This is the cold box that contains two evaporators, completely with valves and safety devices, and also the water glycol system that keeps the system under certain temperature. Don't forget, we're talking about a cryogenic liquid. Minus 160, everything that comes in contact with this liquid suffers cryogenic. This means that we need to use a certain mean in order to be able to avoid cryogenic impacts, and glycol is mean to keep the system at a certain temperature. We operate in extreme environments. With evaporators, I'm not going to display in detail what is inside the cold box. I'm pretty sure that you will have a chance to discuss this with Dr. Theotokrakos and Mr. Ginot on Thursday. I'm pretty sure that they will explain to you far better than me how the configuration is about. But we're talking within the cold box, we're talking about two evaporators. The first and most principal evaporator is the evaporator that transforms the air to gas. This is the main evaporator. The second evaporator is far smaller, but it's also extremely useful, and without it, the system is in danger. This is the pressure built-up evaporator, and the role of this evaporator is to keep a certain pressure within the Type C tank in order for the LNG to be in, let's say, allow me the expression, to be in comfort. So this evaporator here only exists for comfort of the LNG inside. This evaporator here does the actual job of transforming the air back to LNG. Then we have the gas valve unit, and of course through the valve unit we can go to the main end. This is a very basic schematic, but at least it gives you the whole picture of what's going to be brought on board when we're talking about LNG retrofit. Now, a typical tank type C, horizontal type section, cross section, where you can see the outer vessel and the inner vessel and the canopy support. What is interesting regarding the tank of type C is that the IGF code and the class societies are considering this type of tank leakage free. We are talking about a tank that virtually will never face a leakage. How come? It's because we're talking about a two-skin vessel. We have a vessel here. In between, we have a gap which might be filled with a special foam or pearly. And we have the outer skin as a secondary barrier. It is worth to repeat that this of tank is considered leakage free, and this is the reason that class societies are considering the space where these tanks are placed are as non-hazard areas. This is important for you to keep that in mind. A typical station is actually normally, typically the constructor of the tank also constructs the bunker station, and then this comes on board as a box. We have, of course, the bunker connection to the outside source. We do have the vapor which returns vapor, LNG vapors, and this is the purpose of good safety. And we have the nitrogen pipe which is being used for inerting. I'm sure you saw this bunkering procedure back in Finland last time, so this is familiar with you. Box, more or less picture. The core is this brown box, completely closed, and there are only connections for ingoing circulation. This is, let's say, for example, the bunker station. This is the supply, this is the nitrogen supply, this is the cold flare or the relief valve, and this is more or less what you are seeing on board a vessel. There are other types of tanks as well. For example, type D, which is merely used, and we also have the metal tanks, which are commonly used on board vessels and on land applications. We're talking about type C tank because it has a number of prongs that are very useful for operations on the restricted areas of ships. First of all, we do have a working pressure on 2 bars. Normally, this tank operates within the range of 6 to 8 bars. All of them can working for more than 10 bars. So we are talking about a high pressure capability. We do have a superior insulation that actually makes them leakage free. We do have the boil-off control, which is the proper circulation of the gas. The design has proved itself. It's a proven and a robust design, and there's a very simple installation. It's more a plug-in case, and not as easy as that, but any case can be described like that. And of course, the production availability is and let's say accommodate this figure, the production figure, into your retrofit schedule with ease. The cost of those tanks, first of all, we're talking about higher cost. They are much more expensive than other types. The volume is somehow restricted to close to 1,000 cubic meters. This does not mean that there are no Type C tanks with larger capacity. The industry more or less categorizes Type C tanks in the range of the upper limit of 1,000 cubic meters. And we do have low volume utilization. This might be critical, and let me explain to you what does it mean. It means that the tank should never ever be filled to the top. We're talking about that the maximum percentance of filling should be to 19%, no more. It sounds a gap, but this gap, in case of liquid, gives certain amount, which the Type C tank does not permit to get advantage or to be in advance. And the reason is that the Type C tank must be maintained under pressure, and this is why we do have the evaporator, the built pressure evaporator that I showed you earlier, and this is why we are talking about a cone. We cannot make use of the full geometrical capacity of the tank. So, what is very simple schematic? We are talking about cold flare, the inlet for the bagging station, control valves, and various ancillary systems. More interesting discussion. Flow diagram. Flow diagram is essential because it gives the designer the view of the system to be installed. It gives a snapshot of what's going on board the vessel once the LNG equipment will be in place. Before we're talking about the bunker station complex, which includes supply, the control valves, and the transportation pipeline towards the tank. Talking about the Type C tank with all the necessary connections. We're talking about the cold box or the regasification system. You can see here, for example, the two lines I mentioned before. This is line, the output line goes to the main, and this is the line that returns gas into the tank in order to keep the pressure. Go back to the critical question, where to place the LNG tank and the other equipment like inside or outside. A very fast clarification, very quick clarification. The cold box should be the tank. You cannot, for example, install a tank in position A and install the cold box in position B, which is 50 meters away. This cannot work. In optimum conditions, the cold box should be next to the tank, collided, allow me the expression, with the tank. It is permitted to move the cold box a few meters from tank, but out of there. You cannot install, you cannot have a great distance between two components. So, coming back to the question, inside or outside, of course, as you may understand, we do have a straightforward answer in case there is no space. In either case, for example, we don't have inner space and we don't have outer space. If we don't have any space, then sorry, but the design is finished. Then your ship is very small or doesn't have any space, and please do not consider this vessel for LNG retrofit. In case that both options are available and then it's not a straightforward answer. This means that we need to go back to the ship herself and to the owner and start raising additional questions. For outside installation, for example, we need to review very carefully the deck area, the proposed deck area, if a safe distance for any accommodation block, panel area, for any life, any air exhaust or air inlet, anything that might obstruct the typical LNG operations, or anything that, in case of a failure to LNG components, affect from the LNG, from the escaping LNG. The question is, are there going to be any cargo movements next to the proposed area? With cargo movements, we do need any cargo. For example, that loads a container, a truck that is rolling on or rolling off the vessel, if we're talking about a rope, anything that might jeopardize and bring into a danger case. This is also linked with the other question, if tanks will be located in a safe distance from any gas, from the spread, from the bow, from any vessel side. All these are being addressed to the IGF code, and the minimum distances are written in the IGF code. This is why IGF code should be the Bible for the designer who is willing to undertake such kind of design. The fourth question is a critical one. This deals with the piping from the bunker station to the tanks, and then from the tanks, from the tanks to the engines. Why is the first part critical? If you have, let's say, a long from the bunker station to tanks, and we are in danger of facing difficulties with the pre-cooling procedure. And now your obvious question, what is pre-cooling? Pre-cooling is, what the word is saying, is the activity before the bunkering that keeps the piping from the bunkering to the tank under low temperature in order to avoid cryogenic shock when the cryogenic LNG comes on board. This is a very interesting and very sensitive question, and if we have a long distance then we cannot do that within, let's say, time. We need time in order to pre-cool, because pre-cooling must be done slowly and taking into consideration the fact that we cannot force materials to pre-cool. This means, at the bottom line, the longest the pipes from the bunker to the tank, the longest will be the cooling period before bunkering, and this is going to be a critical issue regarding the operational profile of the vessel. For example, imagine what will happen if a vessel comes to a port 3 hours. She needs to take a large capacity of LNG on board. This means that her bunkering procedure will last for 2.5 hours, and they never thought of cooling, or they missed the cooling. This means that they will do it once in a safe mode, they will do it twice in a safe mode, but afterwards the material piping will start to get tired from the cryogenic effect without the cooling. This means that someday the piping will crack. This is the reason we are considering the cooling. This is the reason that we need time for the cooling. And this guides us to operate the vessel long before bunkering in order to start cooling. It's a sequence of actions, and all these actions should be in the mind of the designer because it's his obligation to inform the final operator of the ship about this difficulty. Please do not expect ship operators to know these minor details. It's your obligation as a designer to brief them and to ask them to consider the facts because the ship will operate different than as it operates on with fuel oil. So the final question is a common. It doesn't really connect to the space. It's a question to both the cases, inner or out. If the proposed area is capable to successfully pass the relevant class risk assessment. Again, story that the class will come forward and will ask from you to prove that your design, positioning, your piping, your method of operation, everything has passed the risk assessment methodology that the class applies for LNG fuel vessels. It's a difficult exercise, I must do. From my experience, assessment is a kind of subjective issue, and everybody might have a different approach on what the proper risk assessment. Okay, I'm pretty sure you will tell me there are tools, risk assessment tools, and everybody use them, etc., etc. This is true, but on the other hand, do not underestimate the human factor. And please do not underestimate the interpretation that everybody gives to a certain perspective of the matter. So risk assessment is a serious, might be a serious showstopper in the whole case, and you should be prepared, well prepared, and ready to deal with it. We talked already about the pre-cooling, and no need to go further than that. But pre-cooling should be written in your minds with capital letters. It might destroy the whole ocean if not properly studied and addressed. You should ask yourself regarding the outside positioning if the ship operates under extreme environmental conditions. For example, if a vessel constantly sails on areas where the air temperature is as an average to degrees yearly, then at least raise this question to the system provider, and you should notify him by telling, okay guys, I have a ship that constantly heat. Is there anything that be notified? Is there something that I need to tell the owner? Any precautions to be undertaken? And if the supplier says, oh, no worries, my tanks can withstand 60 degrees, then of course you will request this in written and everybody will be happy. The seventh question deals with stability. It's a common question. As you all are aware of, the higher we are placing some weights on board, the worse the stability is being affected. You should always check stability carefully of the vessel if we are going to install LNG tanks outside. Of course, you should also consider the structural integrity and capacity of the area to receive those tanks. And please note that we are not talking about limited. For example, in this particular case of Christos Pallas, of the elements that they are foreseen for the retrofit, has a weight of around 60 tons without the cold box. So we're talking about a certain amount of weight that will be placed on the deck, and the structural integrity of the deck should be, of course, be considered. And last but by no means least, the outside area should be evaluated on the deduction of the dead weight of the vessel and if we're losing valuable cargo space. This was the case that we faced in another vessel, another major rope which also used another open deck for lorries, for trucks, and we are planning to install these LNG tanks in this open deck, and we are losing some, let's say, lane meters from capacity. For inside installation, the critical question here is if tanks are going to be in an area that it is within the famous B5 limit. I'm sure everyone knows this B as from marine engineering. For those who don't know what B5, a brief explanation. B5 is a limit that has been adopted by damage stability rules and regulations, and of course reflects the value of the ship valued by 5, and more or less says that everything or everybody and everything that has been installed within the B5 is safe. Safe is a typical explanation from a collision. Anything that is outside the fifth, this limit, the B5 limit, is exposed to the collision. I will show this B5 limit on the drawing room because I'm sure I'm not explaining well to you more things, so I will show it to you on the drawing of the vessel. When we're talking about inside installation, we should take into consideration the minimum distances from the bow, which should be 0.08 of the length of the vessel, and the baseline, which should be at least 2 meters above the baseline of the vessel. We should consider any safety boundary for the ventilation track, the trunks that they will be created. Of course, we should consider that we should review safe egress from the spaces that we are looking at. Again, the structural reinforcement and the structural status of the area in question be investigated. The risk assessment, again, stability, again. And now comes the other question: how we are going to bring those tanks on board? Do not underestimate this topic. It might be very difficult to bring tanks to inside areas of a vessel. In the particular case of the stores, the solution that we gave is to make provisional cuttings on the side hull to slide the tanks inside the vessel and then to close the cuttings. We're not going to bring them from on top with opening on various states. We're going to slide from the dock directly into the vessel. And however, this is a case that will create additional costs and additional time delays when the vessel will be out of the service for the LNG retrofit, and those should be considered in your final proposal to the owner. A typical question, a question that should always be considered is regarding the airlocks. Talking about a closed base, those cannot be accessed. We need to create airlocks in order to the LNG tank area incident, but also to protect us, let's say people on board, that they are coming inside these LNG tanks areas. The airlocks, gas airlocks to these areas should be kept under high pressure. Why this? In order not to allow any gas, let's say, interfere with the outside air, vice versa. The airlock should be in higher pressure than the outside area, not the area, the outside area. All these again are clearly described in the IDF code. Question, the number 10 question, is how the selected position affects the capacity of the vessel and what will be the percent of the lost dead weight. This is a very interesting and very, let's say, a turning point question, because it will affect the final decision of the owner. If, for example, you go to a note stating that in order to accommodate the capacity that has been calculated based on your needs, we do need to sacrifice, let's say, 30% of your car capacity, the owner might stop the project. Say, okay, I'm not interested. Thank you. I will continue with other alternatives. If, however, you are selecting a position that, okay, the tax for sure, but in a place where you know from the beginning that the owner will not have a very strong objection, then you can argue with him, stating that, okay, you're going to lose some cash, but please note that your statistics on the route are stating that this area is being used only, let's say, 10% per year, and there is no influence, negative influence whatsoever in the major areas. The trucks are parked, other cars are parked as well. Might be able to find a place where the, let's say, objections of the owner will be minimized. In this particular case, Christos Pallas, we never faced that problem because the owner was fully aware that he's going to some space, some private car space, and he was the one that told us, don't worry, this area is used very often, and can live without it. So we are very happy with his response, and we continue on. The final question is one of the most difficult ones to answer. And this is how ventilation routing, pressure relief system routing affect other vessels, areas, and installation together with the accommodation areas. Later on, you will see what this question might raise showstopper to the whole design. I don't know. Dr. Boulouris, are we in something? Okay, is
there any question about the first part of the presentation?
Sorry guys, I can't do.
Is there any question about the first part of the presentation of Mr. Bakas?
No.
No, thanks. So we can have a break and continue at 30 minutes for the second part.
Okay, let's have a break and let's come back in half an hour.